Okay.
Ryan, how you doing?
Hi, Stuart. How are you?
Good. How's everything?
Great. You?
Good.
Fantastic.
You liking New Jersey?
Yeah. I'll be here for a while, probably until the end of July at least.
Mm-hmm.
And then after that, our move is to Florida. I'm going to try to start teaching.
What are you going to teach?
I'm going to teach Earth and space science to either middle schoolers or high schoolers. So it should be exciting.
Oh, that'd be great.
Yeah, really looking forward to it.
Do you have a location in Florida?
Yeah, it's probably, but not certainly, going to be in Melbourne. So that's along the Space Coast, right beneath Cape Canaveral.
It's south of Cape Canaveral?
Yeah, it's about 45 minutes south of Cape Canaveral.
Where is it relative to Cocoa Beach?
Oh, it's like the next town south of Cocoa Beach. Yeah.
Yeah, we were down Cocoa Beach and watched a SpaceX go up a couple of years ago. It was very exciting.
Oh, phenomenal. Yeah, those are always a thriller. And I'm glad that, I'll get to teach space science in an area where it's treated with high regard. Other places in the country, space science isn't given as much attention. So I'm hoping to at least bolster the attitude toward it.
Yeah, you could take field trips to KSC.
For sure. Yeah. Here's Deborah.
Hi.
Hello.
Hi, Deb.
Hi there. Hello. So, what's up?
Just getting started. I I actually wanted to begin this with a news article I read this morning. Pretty interesting news. So I'm sharing the screen now. Betelgeuse, the red supergiant star, is going critical.
Oh.
It looks like data that had been collected is indicating that Betelgeuse is not far away from going supernova. And we've known for years now that Betelgeuse could explode at any time, like from now until tens of thousands of years from now.
Yeah.
But, you know, that is pretty much current in astronomical terms.
Yeah.
Wow.
Yeah. A couple of years ago, there was an interesting phenomenon that happened. Betelgeuse looked like it dimmed for a little bit, and it was enough that you could perceive this with the unaided eye. But I think the leading explanation was that some dust had blocked it.
So will this be visible to the unaided eye tonight?
I'm not sure. I think Betelgeuse is starting to sink. It's different, of course, in Wyoming, but in New Jersey,
It is.
I don't think it's quite visible when it gets dark now. It's sort of like getting to below the horizon. But Wyoming, you still might be able to see it after sunset in Orion.
Yeah, you can. You can.
Okay.
But so
it won't be up for much longer.
Right.
How many light years away is it?
About 600, 500 or 600 light years.
This will but this going critical, you think would be visibly different to the unaided eye?
I think the news article that was written, when was this? Today, 2 days ago. So I saw it on my phone today, but this was written 2 days ago, was that astronomers had measured like a little bit of a perturbance in the or perturbation in the brightness. I don't think we could have seen that with our naked eye.
Yeah.
Of course, when it does go supernova, when it explodes, it will be quite the spectacle. It'll be about as bright as the full moon.
Whoa.
And it will shine in this gigantic glow for several days, and it will even be visible during the daytime.
But that's it, just 2 or 3 days.
It probably up to a week, I would say. And this is based on evidence from prior supernovae that have erupted. So there's a story that Chinese astronomers back in 1006, so 1006 AD, had observed a supernova that had lasted for several days, I think 10 plus days, where it was seen during the day and illuminated pretty close to that of the full moon.
Do they know how far away that supernova was?
Yeah, so this was what is now the Crab Nebula. And the Crab Nebula is, let me just refresh my memory, is 6,000 light years away.
10 times as far as Betelgeuse.
That's right. Yeah. So, you know, this was an immense explosion. So yeah, the age is 1,001 years, meaning the nebula was created during humanity's existence, which I think is pretty cool. That's not a common thing for astronomical objects.
Yeah.
But yeah, just quick current events that I read up on this morning.
Astrobites.
Astrobites, yeah, that's the website. So it's coming soon, but of course, soon could mean centuries from now. Yeah, and people, of course, wish they would be able to see it in their lifetime.
Well, I hope it happens during our winter so we can actually see it. It won't be
I hope so
gone
too.
in the glare of the sun of the
Mhm.
the spring, summer.
Yeah.
Yeah.
So, okay. Today's film was Europa Report,
It's this.
and this was a really interesting film for me because it was kind of like more realistic than a lot of the other movies we had seen, with aliens and time travel and going across the galaxy. I mean, this was as close to reality I think we've seen so far, when you have a group of astronomers trying to search for extraterrestrial life, and a trip to Europa is in the plans of a lot of space agencies. This is one interesting body in the solar system for a variety of reasons. The first thing was the scene where the
Hydrazine.
Yeah, well, he had hydrazine, which would have contaminated the cabin. I'm just blanking on his name. It was
Hydrazine.
yeah, but
They
the
were-
name of the person
You
who
guys
got it,
looked- Yeah.
the name of the
Yeah.
person who had it on his suit. Anyway, it brought about a really interesting question. How long could you survive in space without a spacesuit? So last week, Deborah and I had discussed what it would be like to be in space for a long period of time. So what regular astronauts experience when they're in orbit for several months.
Just as an aside, his name was Bloke, B-L-O-K, Andre Bloke.
And what was the other one who got
James
pushed away?
Corrigan. James Corrigan.
That's it, Corrigan. Okay, thank you.
Andre.
And so we discussed like what happens to astronauts when they're in microgravity, and what happens is your bone density can decrease, you grow a little taller because your spine decompresses, your heart shrinks a little bit because it doesn't have to push blood against gravity.
I need that.
And among other things, you can develop cataracts in your eyes, a host of other biological effects. And then we discussed, well, what would happen if a fetus developed in space? What if you were born in space? What other things might, you expect? But now this is a different question where it's like you're perfectly fine and you're in microgravity, but you decide to take off your spacesuit. And what happens to the human body when you're exposed to a near perfect vacuum? You might
Stuart can tell you all about that.
You experience this in Wyoming, in fact, a little bit compared to being at sea level. And I know for me, it was a more dramatic effect because I run a lot. And I noticed when I was exercising in Jackson Hole, which has an elevation of above 6,000 feet, it felt a lot more strenuous than it would be at sea level where I am in New Jersey, where I live. Another a misconception is that running at altitude or exercising at altitude is harder because there's less oxygen. But it's actually not the case. The oxygen density in the atmosphere is pretty constant. What makes it harder to breathe is the barometric pressure. And
I wouldn't say the density, I would say the percentage.
Percentage, that's a better word. Yes, thank you.
Yeah, because the partial pressure Yeah,
Yeah, numeric density. Yes, percentage is a much better term, of course.
yeah.
So your lungs are a little bit pressurized. They're a little bit less than atmospheric pressure. So when you draw air in, it's pretty effortless because air wants to rush into a lower pressure region. What happens when you move up to altitude is the barometric pressure drops. And now there is less force pushing that air into your lungs. And you need to work harder to get air down your throat and into your lungs. So it's not that there's less oxygen, but it's literally harder to draw in atmosphere.
Well, there is less oxygen. Because the percentage stays the same, but the number of molecules is less because the barometric pressure is less.
I think you're right.
It is the number, the number of molecules, and you need that number to.
So it might be both facts.
Yeah.
The one that each of you is saying.
Right. I think you're right. I'm not sure how much more the pressure is responsible for it being harder to breathe. Because although there is a little less oxygen because the air density is lower, what I read doing my research is that the primary reason it's harder is that there is less barometric pressure. Of course, a secondary reason, and I'm
Well,
not
the
sure to what
barometric
degree.
pressure really only has to do with the number of molecules. It's not the pressure per se. Yeah.
But the number of molecules is directly a result of, or a cause of, how much force is pushing in on something
force
else.
Force is not the issue.
Is it?
Force is not the issue. No, it
I'm intrigued by this.
It doesn't. Yeah. Look up the work of Peter Auerbach, Paul Auerbach, Peter Hackett.
Well, here, this one thing, and this is probably one of the things I read, but it says training altitude is beneficial because the air is thinner. Oh, wait. It's not the lack of oxygen that makes your body work hard, so altitude, it really has to do with the barometric pressure. Even at 10,000 feet, there is still 29% of oxygen.
29%? It's 21%. So already this is invalid. Okay. So find some other source.
What was the name you had suggested? Peter?
Well, there's all sorts of high altitude medicine that goes on, and maybe not a medical thing like this. I was thinking about some of the things that you were quoting before, and some of the medicine you're getting is kind of like the anti-vaxxer. If you listen, it's all in the source. So don't get your medicine from YouTube. But there's a lot of high altitude medicine knowledge and research that goes on. So Peter Hackett has written a lot. I guess Paul Auerbach is more, well, he's at the other end of the spectrum. He's more of a scuba diver. So so there you have multiple atmospheres of pressure going, as you.
Yeah, okay.
Ascend
I'm
to
trying to
one
find out.
atmosphere of pressure. Yeah. It's not the pressure per se.
And the link I pulled up at first actually wasn't the first one I read, but it had said the same thing.
Yeah.
So I'm trying to find out where it says lack of oxygen is the reason that it's harder to exercise.
Well, after you've been here for 3 months, it's not. And that's because you make more hemoglobin to carry it, to scavenge more oxygen out of that 21%. So that's not the pressure.
Yeah, so that's a good point. That is convincing to me, because why does your body go out of its way to create more hemoglobin?
Because it perceives because the kidneys, where the hormone that makes for more hemoglobin originates, they perceive low oxygen in the blood.
All right, I really have to do more reading on this, because clearly I was
Like, were you on New
misled.
Jersey? Well, yeah, it's the sources. It's like that physicist saying that your stomach gets poisoned because you're lightheaded.
Oh, right, yeah.
Yeah. It's like listening to anti-vaxxers or Trump on YouTube, or whatever.
I see.
So this, Peter, this will be the best of the best.
Okay.
I mean, I don't know this per se, but
Yeah. So I wonder.
that's.
So yeah, going with the idea that it's harder to exercise because there's less oxygen going into your blood.
Yeah.
Is having just a lower pressure have any effect on the human body and its like perceived level of exertion? Like, I guess the very first few days that you're at altitude, you do need to like work harder to bring air into your lungs, but like, does your brain perceive that as like a difficult effort? I'm wondering.
Well, it's not. It's because you don't have the oxygen carrying capacity. There's like a 3-week adaptation, and there's a 3-month adaptation, and it has to fix the oxygen in the hemoglobin and the tissues. And then there's another issue of that we're not all born the same way with the same ability to have high altitude medical problems and others not. And you can't train.
Yeah, you can't like train yourself to have more red blood cells. Like, for example, a good example is like Sherpas in the Himalayas. Like, they've developed such a great capacity to breathe, 15,000 feet of altitude air. Is that
yeah,
like
but that's
similar?
it's a different. This is a different. No. Well, you'd have to read some high altitude medicine, not exercise gurus, and I don't know, for sure.
Well, I'm just reading something that says,
I mean, this is a long time ago for me.
It says the oxygen drop combined with the decreased air pressure, packs a 1-2 punch to your cardiovascular system. So
it is a little bit of both, but I'm guessing that the lack of oxygen is probably the bigger of the two influences. But that's really cool, and thank you for encouraging me to read further into this, because I've told a few people about this. I was like, oh, did you know
But that's
about
only, yeah. Well, but the bigger issue of being without a spacesuit is the lack of pressure. It's like getting the bends when you go, when you're diving, you know.
Yeah, see exactly what you mean. So if you're exposed to like a
100
vacuum
feet. Yeah,
it doesn't matter how much oxygen is there, your body is literally going to explode.
Yeah, there was some science fiction movie that showed that you know, somebody's suit failed and they were, you know, freezing while they were
writing this down.
Exploding and getting hypoxic, of course.
Total Recall, Arnold Schwarzenegger. There's some.
Oh yeah, and I think Sam did that one. Sam did that presentation. Yeah, and
but
so
there's another thing. I think in space they don't. I think in the space stations they don't have the other, you know, 79% nitrogen, which is the big issue that causes the bends. Do they do helix or something else? Well, they don't talk like that. They don't talk like that.
Right. Yeah, I'm wondering. I'm not sure.
But they do something less likely to get the bends.
Right. Yeah. And you know, in addition to I guess your lungs kind of exploding if you were exposed to outer space, like you said, your bloodstream would start boiling.
Yeah.
And then I also looked up hydrazine and like
in your tissues, you know, when you have. Yeah, go ahead. Yes.
So I looked up hydrazine and like exposure to hydrazine and what happens. And apparently it's a similar compound to ammonia, and it can cause like nausea, vomiting, and even like blackouts and comas.
Coma and death.
Right.
And it breaks down, to ammonia. It sounds like, well, it must be a very reactive molecule because it's used as a propellant, right?
Yeah.
Yeah. So that was an interesting thing I learned that I had no idea hydrazine was a thing. I never heard of hydrazine, and I looked it up, and it's a pretty interesting chemical.
Yeah. Yeah.
So here's like a paper on acute exposure levels, what the guidelines are.
Where else is it used besides propellants?
There were other places.
It's been around for a while.
Maybe in making polymers? Was it something like that?
Yeah, flexible and rigid foams. Also pesticides.
Yeah. It's very simple. The nitrogens are bonded, and they each have two hydrogens. But it's so simple. What makes for a propellant that it's unstable? I mean, what is it? Is it oxygenated to make it explosive? Oxygen scavenger. Yeah.
Right. Yeah. So, and I think, if I'm correct, like when they launched the space shuttle, for instance, they have liquid oxygen as like their fuel source, and it's being ejected from the bottom.
Well, yeah, the shuttle had a huge oxygen tank.
Mm-hmm. So I'm wondering if that, like, because, you know, rocket engine is far different from like a combustion engine. So, you know, I'm wondering like what needs to be ignited, or is it the ignition that triggers this like massive expansion of gas? And if that's all thrown underneath, like you have that equal opposite reaction. So the way I picture rockets is just like dumping fuel as rapidly as possible to get lift.
But it looks kind of fiery, like something's combusting, right?
Yeah, exactly.
It's not just expansion of a gas and extrusion.
Yeah, I didn't study much rocket science, but we did learn a few things here and there in one of my graduate level courses. It was a lot of fun. We learned about, I think we learned not so much the chemical engineering part of it, but like orbital mechanics and like the delta V and how you need to change your orbit to get into whatever level you want.
Yeah.
So it sounds like hydrazine, it's passed over catalysts such as iridium, and it decomposes into ammonia, nitrogen gas, and hydrogen gas. And the first two reactions are extremely exothermic, and they produce large volumes of hot gas from a small volume of liquid, making hydrazine a fairly efficient thruster propellant with a vacuum-specific impulse of about 220 seconds, whatever that means.
So it's more expelling the gas than
when it breaks down.
uh-huh.
Thank you.
Yeah, super fascinating. And
Perfect.
so the other thing,
I'm gonna go on. I'm gonna black out my video because I'm gonna eat. I have to eat dinner now. So
okay, yeah, sure thing.
Right here.
One of the big components of this movie was obviously Europa, and what makes Europa so special is it has this subsurface ocean. So you can see like a cross section here. There's an icy crust, and this you may think of sort of like the continent of Antarctica, but surrounding the entire moon. And then there's these little like cracks and fissures underneath, suggesting that it's pretty fragile and prone to movement. And you see these jets, and I kind of cut them off, but they're spewing out volatiles. This is an example of cryovolcanism, and they don't really look like volcanoes, but you can think of them as like thermal vents. And instead of molten rock being spewed out, it's more like droplets of methane, nitrogen, maybe some oxygen, and you know, other gases that would probably most likely be a liquid at this temperature, which we're talking minus 200 degrees or so.
What they said as they landed, but one of the ladies said was, "Oh, it's absolute zero, and it's covered in ice 11." So of course it's not an absolute zero. Yeah. And so that got me looking up the different types of ice. Yeah.
Oh, yeah,
well,
ice
I knew,
11.
Yeah.
That was something I had never heard about either. So it's sort of in like a crystalline structure.
It's a different crystal, different shaped crystal.
Right. And you also have other numbers like ice 2.
Well,
ice 6.
it was before your time, and it's mentioned as you go looking around different types of ices. But there's a book called Cat's Cradle, written by Kurt Vonnegut. And the big catastrophe is that somebody had synthesized ice 9. So that was like 40 years ago, I heard about this, the possibility of other crystalline forms of ice. And the problem with ice 9 in the book is that its melting temperature was like 60 degrees. So if you dropped it in a glass of water, it would freeze the glass. And
That's
it would freeze
crazy.
the oceans. Right.
Wow.
Yeah. And I don't know if that's true about, the truth if you looked up ice 9, but that was the thing in the book. That was the impending catastrophe.
Wow, incredible.
Yeah. But most of these different ices, they're, see, it says minus 72 Kelvin, minus.
Yeah.
Yeah. Most of them solidify at very cold temperatures, but not absolute zero, like whichever chick that was. Yeah.
Yeah, that's true.
Yeah. But they found the latest is they found ice 19. Some guy in Austria is the major dude for these different forms of ice. Innsbruck, maybe.
Wow.
So that's ice 19 is the latest.
These
So
are
it
all
takes-
Roman numerals.
Yes. Well, actually, I just put in like that. Oh.
Oh yeah, exotic
these things,
crystals.
Are these things discovered or are they synthesized?
Synthesized. They could be on another planet, of course, but they involve pressure and extremely low temperature, so they're being synthesized.
Yeah, so this one says like ice 19 only exists in laboratory experiments, but you could find stuff like this out deep in the solar system. So I wonder if like Pluto is a hotspot for exotic ice crystals. That would be interesting.
Yeah.
Or even the well, no, not really. No, forget that. I was thinking about the moon, but
Yeah.
no, there's nothing but dust on the moon. It's very barren. But yes, go ahead.
Okay, so when I looked at the cross section they had of Europa on Mr. Google, isn't there a relatively hot core?
Relatively, yeah. And I believe, well, I can even move this down. So underneath you see hydrothermal circulation.
Yeah,
and it's like colored red a little bit. So I believe this applies to most solar system bodies that, early in the solar system when everything was flying around this proto sun, things were pretty hot because you think about it, everything in the solar system came from the sun. And no matter what, you're bound to be some reasonably warm temperature or, raging hot like the center of the earth, which can be upwards of 10,000 degrees. Of course, the smaller you are, the faster you're going to lose heat. And if you're cast out and deep into the solar system, right, you're not going to be receiving much energy from the sun and you'll cool off really rapidly. But, the core of Europa, for instance, hasn't been stripped away of its heat as quickly as Europa's surface, and therefore it can be relatively warm deep underneath the ocean.
Mhm.
And another thing is this cross section is very zoomed in. If we really want to take a look at the whole planet, I'm sorry, the whole moon, we can go to this NASA website, and some of Europa has been mapped. So we have
Yeah.
some ridges and other features, not many craters going on here. Not a lot of craters.
These are ridges of ice.
Yes.
Like tectonic. Yeah.
This
So
is
that is
basically,
interesting. Why aren't there craters there? Isn't it being pinged by asteroids the way the moon and Mars
Yes.
are?
yes, and you're right. What I learned from my astronomy class in undergrad was that
Yeah.
since this is made of ice, if you have an impactor crash through the surface, right, it'll leave a hole, sort of like what you use when you do ice fishing, but then eventually it'll close back up.
Yeah, of course. Right.
Well, does the ice isn't like geological strength. So does it move around over time?
I would
You know,
imagine. Yeah, I would think of this.
characteristics.
I would think of this whole crust as like the continent of Antarctica. And of course, just like all the other continents on Earth, Antarctica is subject to movement because it's part of the Earth's crust, which kind of floats, if you will, on the mantle. And for Europa, you can draw an analogy and say, all right, Europa's mantle is this ocean, but it's a lot thinner than Earth for comparison. So if you slice it open now,
Yeah, that's the view.
yeah,
So
you can see that this ocean is really, really thin compared to the rest of the volume of the moon.
So you need to just design your things and propellant so it doesn't melt through the ice before it gets up in the air.
Oh,
That's what
yeah,
happened.
of course.
Well, that's what happened to them. They melted the ice before they could get.
Yeah, and it's interesting, like
lift.
what kind of temperature you would need to produce in order to melt this ice. Because my understanding is deep in the solar system, when you're dealing with temperatures under like negative 200 degrees, this ice is rock hard solid, almost like a metal. And it's surprising to me that they could create a temperature hot enough to melt this ice. That I find I'm a little bit skeptical of that. I would say it's not impossible, but I'm intrigued to find out how much you'd really have to heat the ice to melt it.
How thick is the ice there? Do you think on Europa?
I think it was like 15 kilometers, wait. 5 kilometers. So, about 3 miles.
Mm-hmm. It's a lot of
Europa's
ice.
surface temperature never goes above minus 260. Yeah. Fahrenheit. And then at the poles, where there's less sunlight, we're talking 100 degrees less. Minus 370 Fahrenheit. So how much is that in Kelvin, just out of curiosity?
130 Kelvin is 225.
50 Kelvin. 50 Kelvin at the poles.
So it is near absolute. It's near absolute zero. Yeah.
Relatively close, yeah.
Yeah.
Only 50 Kelvin above absolute zero.
Yeah.
But the really interesting thing, not so much Europa's composition, how cold it is, what the structure looks like, is that it's, how do we know it's there? How do we know there is a salty ocean underneath the ice crust? Because obviously we've never been there, and we are unable to send probes beneath the surface. How do we know there exists an ocean? And I think I touched on this briefly before, but we used Lenz's law to discover that there's a salty, the saline water fluid on Europa. And the way we know this is that Europa perturbs the magnetosphere of Jupiter. Jupiter has a gigantic magnetosphere, if you want to take a look. Maybe I can even throw up an animation to show the relationship between Jupiter and Europa here.
Is Europa the largest moon of?
Ganymede is the largest. I think Europa is the second largest. So
These
okay.
are one of the 4 Galilean moons, right?
Correct. Yes.
Of the 79.
That's right. Yeah. Okay. So you can kind of think of Jupiter having this magnetosphere that looks like this, and you have these concentric ellipses. But then you notice at one point, this ring gets distorted a little bit. It wiggles. It's not a perfect ellipse. And this distortion was created by Europa. And, you know, this is interesting because Europa,
Oh, that was Jupiter's aurora. That just came out last week or so. So it's interesting to me that there's so much sodium Earth.
Yeah.
So we have ways of measuring or observing the magnetosphere of Jupiter.
Exactly. So we know that Europa probably doesn't have a magnetosphere of its own, because in order to do that, you need some circulating convection in the core or just outside the core, like the Earth does. Like the Earth has a pretty strong magnetosphere because we have an outer core that's like swirling around. We have this molten nickel sphere, basically, or shell. And that spinning is creating magnetic field lines radiating out from the Earth. Jupiter has this as well. Jupiter has the largest magnetosphere of all the planets. And we're like, okay, Europa doesn't have one of its own, but it's still messing up Jupiter's magnetosphere somehow. And they're like, how is this interference even possible? And the conclusion is that Europa has some charged particles in it. And this is possible if you have salt water, because in salt water, when sodium chloride dissolves into the water, you have free ions. You have sodium ions and you have chlorine ions. And when you have charged particles in a magnetic field, you induce another magnetic field. And so it appears that Europa has one of its own, even though it's not the case. So it has like a what do you call it? An effective magnetic field. It's do you call it? It I'm blanking on the word now.
It
but
simulates a magnetic.
yeah, sort of. Induced. That's the word I'm thinking of. Induced. So Europa induces its own magnetic field because it has charged particles, which are interacting with Jupiter's magnetic field. So that was just sort of
As opposed to the other moons of Jupiter.
That's right. So the other moons don't have dissolved ions anywhere in them, so they don't induce any magnetic field. But yeah, that's sort of what I learned as an undergrad, why Europa was so fancy. And what we did is a demonstration of Lenz's law. And I don't know if you've ever seen this performed, but what you can do, and you can do this on a budget actually, you can go to Home Depot and get a couple of magnets and a copper pipe. And all you do is you hold a copper pipe and then you drop 2 magnets down the pipe and they fall in slow motion. Have you ever witnessed that before?
No.
So let me bring this up real quick.
Oh.
So the copper pipe is not magnetic. And so if you drop an iron ball, nothing's going to happen. The copper pipe doesn't exert a magnetic field. But you put a real magnet in there and it falls in slow motion. So even though the copper pipe isn't magnetic itself, because you're dropping a magnet into something that's really conductive, copper is one of the best conductors of electromagnetism. You now make the copper act like a magnet and it pushes up against gravity. And this is like, what's it called? I think an eddy force. And it's opposing gravity, so it acts against the falling magnet. So you can think of this like an analogy. The ball being Jupiter, because Jupiter already has a magnetic field, we know that. And the copper pipe is like Europa. Europa doesn't have a magnetic field on its own, but once you put Jupiter in a system with Europa, you can turn Europa into having a magnetic field. And you can turn this copper pipe into something that acts like a magnet. And
It's like having coiled wire electric current creates a magnet. Right?
Yep. So here is from the top view. I did this with my middle school students. I brought a copper pipe into class and I let them drop magnets through it. And really fun time.
Now it seems from this view, it looks like the magnet is rotating. Does that have to do with something?
It's just sort of like tumbling because it wasn't released.
Even okay. Just an artifact. Okay, so what's coming up the pseudo-volcanism thing there?
Yeah, the cryovolcanism.
Yes.
So this happens when you have any sort of heat movement beneath the crust. This is also evident on Saturn's moons, one of Saturn's moons, Enceladus. Enceladus also has a bunch of cryovolcanoes. They're little plumes of jets, like water ice, not water ice. It's not water, it's some other chemicals. They could be liquid water depending on what the temperature is. So you think of like Yellowstone has the geysers. Geysers are an example of cryovolcanism. It's basically any material being ejected from the ground that's not lava. That's pretty much the definition of a cryovolcano. So in this case, what do we have? Okay, sometimes it is water vapor. Sometimes it's methane.
Yeah.
Methane and water, I would say, is probably the most common ejecta. So here, another example of an icy crust in a liquid ocean. And we think Europa is pretty similar like this.
And okay, so that's interesting. So it's olivine in water, which is a silicate. Huh.
Yeah, from the rocky core. So now this is like the rocky material that makes up the inner part of the planet.
So is the rocky core molten, or it's just warm?
It's warm. I doubt this rock is molten. Especially since, look, you have heat being removed by the ocean through these vents. I can't imagine having any liquid rock at this depth. Because heat should very easily be able to escape through here.
So that movie was very realistic, except for the octopus at the end, right? That's probably unlikely to be there.
The fluorescent octopus.
Yeah.
Yeah, and that's great that you brought that up, because that was my final point for tonight, which is, what would be considered a living thing? And I think we had a little bit of a discussion like this before, but I think a great question that frames this concept is, when could you say in a newspaper, for instance, that, all right, we legitimately found extraterrestrial life? What's the threshold for saying, all right, we definitely found something that's called life? And, this is up for interpretation. I don't think there is a right answer.
Mm-hmm.
Because, journalists like to run away with exciting titles like, oh, we may have found the slightest evidence of something that looks like life, and make that into life exists outside of Earth.
Mm-hmm.
So if you want to be as objective as possible and scientifically rigorous, where would you say the line is for something that's living? And I think one of you had mentioned, it has to reproduce.
Mm-hmm.
It has to, but what if we don't ever get the chance to see that happen? What if we find, what we'd call an organism that's moving around, it's feeding, but it never makes copies of itself. It's sort of just on its own. And we're not around long enough to see it go through a life cycle, for instance.
Well, I guess if you're seeing something that's feeding and moving around, it sounds like the old definition of pornography, which the Chief Justice said, well, I can't really define it, but I know it when I see it.
Yeah. Yeah, that's a valid point. Yeah, and the reason I bring this up is I think a lot of scrutiny needs to be put on the people who are responsible for spreading news about new discoveries in space.
Not anything. Well, you brought this up last time, but I'm just, asking Mr. Google what he thinks. And the philosophynow.org says, and I'm not sure I particularly, but you agree with this, but you and they put in the word evolves.
Right.
I don't know if things have to evolve. I think they just have to replicate.
Yeah.
And have some form of, they're not just random molecular structures. They are organized structures that permit replication.
Of course. And if it's up to us to find out what kind of life is out there, we may not be able to stick around long enough to see anything evolve, because that takes,
right,
several millennia, if not millions of years.
I mean, I don't know if you say a paramecia evolves. Maybe I'm putting a value on intellectual evolution, or is it evolving into another type of organism?
Good point.
I don't.
Yeah.
So I don't think that's necessary. A paramecia is still alive as it is.
Right. Yeah. And, maybe there needs to be a strict definition for evolution. Is it bringing down traits to future generations? Is it the passing down of characteristics, physical and mental, if there is any mental characteristics to be passed down?
Yeah.
Or is it just, very simple changes that occur? Could, like, a caterpillar turning into a butterfly be a form of evolution? Sure.
Only if it was permanent. No, that's not evolution. Unless it permanently was only, a butterfly, was born as a butterfly.
But yeah,
that's, that's some form of metamorphosis, not evolution.
So I got to go in a second. My last question is,
Right.
of all these places to visit, I guess there's pros and cons. We're sending something to Titan, and have we sent things, or are we sending things to Europa and Io and what's the other one?
Callisto, Ganymede.
Yeah, Callisto and Ganymede.
Yeah.
I think of the 4 Galilean moons, Europa is the best candidate for extraterrestrial life. And I have not actually read up on planned missions to Europa, but I've heard rumors. Let me just double check this. So
I wonder how easy it is to go there versus Titan.
Yeah, and you may think, all right, Saturn's just the next planet, but it's actually twice as far away as Jupiter. So, but here, planned missions to Europa, they begin this year apparently, and should be complete by 2023, according to this JUICE mission, which I've never heard of.
I saw that as I was looking up stuff.
Icy Moons Explorer, yeah. Oh, so 3 of the moons actually. Europa, Callisto, and Ganymede. So this is an explorer.
It's a flyby.
Yeah. So I was thinking, like, visit Europa with like landing gear and stuff. I'm not sure about that. I would have to do some more reading.
Talk to you guys next week.
Okay. Thank you, Stuart.
Bye, Stuart.
See you guys.
So so next week I just saw is Armageddon.
That's right, Armageddon. Yep.
Okay. That's, I'm sure I haven't seen it, but okay, well, we'll see how the week evolves. All right. So that was a bunch of interesting things to discuss there. You know, the other, you were talking about spacesuits. What was the one we saw the week before with where all the astronauts were criminals and there was this baby making going on?
Oh, High Life.
Highlight. Their spacesuits, were like, made from tablecloths.
Yeah. They didn't look very durable.
No, not very pressurized or anything. And this movie, sometimes there was no gravity and sometimes there was.
Yeah, and that was kind of surprising to me. I was like, wait, how come they're not floating around? But then in another scene, I saw what looked like the spacecraft was rotating.
Yeah.
That could possibly explain how they were able to create their own gravity.
Yeah.
I'm gonna just like stick with that assumption and say, okay, it's legitimate if they.
Okay. I think they were just inconsistent. Sometimes they did it and sometimes they didn't. They're movie makers. Yeah. Okay, we'll see you next week.
All right, thank you, Deborah. I'll see you Wednesday.
Right. Thank you.
No problem.
Bye. Thanks for doing this.
No problem.